Hello viewer, welcome to Samuel Academy. My name is Samuel. In this video, I want to discuss about energy levels, sub-energy levels, and orbitals of electrons around the nucleus of an atom. This information will help us to be able to write the electron configuration of a given atom. Let us begin. In that image, I have a model of an atom which has a central nucleus and it has energy levels, sub-energy levels, orbitals, and electrons in those energy levels in the atom. So I want to explain what that means. Okay, from the nucleus, we have energy levels. The first energy level around the nucleus is called the energy level N is equal to 1 or K. So this is the first energy level. Then after that, we have the second energy level, N is equal to 2, or L energy level. After the L energy level, we have the energy level N is equal to 3, or M, this one here. And then finally, in this model, we have the energy level N, okay, this one here, or N is equal to 4. Okay, we have up to 7 energy levels, but in this model, I'm discussing only the first 4 energy levels. Now, after energy levels, we have sub-energy levels. Let's look at the K energy level. This K energy level, which is around the nucleus, has one sub-energy level. This sub-energy level is called S. So in this energy level K, we have this energy level called S. It has only one S. And this S sub-energy level has one orbital, right? It has one orbital. And each orbital has 2 electrons. So that one orbital, the S orbital, has 2 electrons. All right? Like in the case of helium, the first energy level has one sub-energy level with one orbital with 2 electrons, and nothing more. Okay, let's look at the energy level L, that is N is equal to 2. This energy level L has 2 sub-energy levels, S and P. We saw that S has one orbital with 2 electrons. So this energy level, this is the sub-energy level S, that is in L. S has one orbital with 2 electrons. Then we have the P sub-energy level, which has got 3 orbitals. 1, 2, 3. Each orbital has 2 electrons. So the P sub-energy level in L has 6 electrons. Okay. Now, let's go to the third energy level, N is equal to 3, or M, this one here. This energy level has 3 sub-energy levels, S, P, and D. The S sub-energy level in this energy level, The S has one orbital, okay, this one here has one orbital with the 2 electrons. Then we have the P subenergy level with the 3 orbitals and 6 electrons. Then we have the D subenergy level, okay. In this energy level M, we have D. D has 5 orbitals. Each one has 2 electrons, so it has 10 electrons in the D, okay, in the D subenergy level. That is 5 orbitals with the 10 electrons. And finally, the N energy level, this one here, the yellow one, it has 4 subenergy levels. That's the S with 1 orbital with the 2 electrons in it. Then the P subenergy level, which has 3 orbitals with 6 electrons. The D subenergy level with 5 orbitals and 10 electrons. And the F subenergy level, which has 7 orbitals. That means 14 electrons. So that is how we can, the information about energy levels, subenergy levels, orbitals, and the number of electrons. Okay. So remember, the S subenergy level has 1 orbital. And each orbital, in every case, has 2 electrons. Okay. So that is what we have. So let us see how we can use this information to write the electron configuration of various elements. Okay. So, but before we can do that, we need to know that these sub-energy levels, they have relative energy of electrons. Okay, sometimes there is an overlap, all right? So when you are writing the electron configuration of a given atom, this is the pattern we follow. So depending on the number of electrons in that atom, this is the pattern we follow. The first energy level, okay, has 1 subenergy level, S, with the 2 electrons. The second one has S as the sub-energy level with the 2 electrons, like that. Now let's look at an example to understand what I'm talking about. Let's consider the case of zinc, okay? Let's look at zinc. Zinc is number 30 in the periodic table, therefore it has 30 electrons, right? And 30 protons, but we are looking at electrons. So 30. So the first energy level, okay? The first energy level, that is the K, which has got 1 sub-energy level. It has 2 electrons. That's why we have the 2 here. The first energy level with 1 sub-energy level and 1 orbital has 2 electrons. Now we are remaining with 28 electrons. Now the second energy level has 1 sub-energy level, the S, with the 2 electrons, and it has a P sub-energy level with the 6 electrons, because the P has 3 orbitals. Each one has 2 electrons. So we have 2s2, 2p6. This is the second energy level. So these are how many? 8 plus 2, they are 10. We are remaining with 18, okay. with 22. Now, this one is the third energy level. Okay, the third energy level has the S sub-energy level with the 2 electrons. It has the P sub-energy level with the 3 orbitals, and that means 6 electrons. And before we proceed to the D in this third energy level, depending on this order of relative energy, we find that this one comes first. The first sub-energy level in the fourth energy level comes first before you go to the D in the 3. So this one comes first because of the order of relative energy. So after 3 third energy level and the P sub-energy level, we don't go to the D sub-energy level. We go to the S sub-energy level in the fourth energy level. So we have 2 electrons. We have the 4th energy level, and the S sub-energy level with the 2 electrons. Okay. Now after this we go to the D in the third energy level. We go to the D sub level. Okay. And D usually has got 5 orbitals, so it has 10 electrons. So in that case, for zinc, we have exhausted, we have completed, we have written the electron configuration. We can count this 10, 12, 18, 20, 26, 28, 30 electrons. So we are using this order. Start from the first energy level, which has S sub-energy level with the 2 electrons. That one's complete. You go to the second energy level, and it has the S sub-energy level with the 2 electrons. It also has the P sub-energy level with 6 electrons. From there you go to the third energy level, which has the S sub-energy level with the 2 electrons. Then it has the P sub-energy level with 6 electrons. And before you proceed to the D, because of the order of relative energy, you go to the fourth energy level and the S sub-energy level with the 2 electrons. Then finally, we have the third energy level with the D sub-energy level, which has 10 electrons. Now, if we divide this into the usual electron configuration, the basic one, we find that this is the first shell with the 2 electrons, which is complete. This one here, 2, is the second energy level or shell with 8 electrons. 6 plus 2 is 8. Then the third energy level, usually when it is full, it has 18 electrons. So we have the third energy level is 2 plus 6 is 8 plus 10 is 18. Okay, that's 18. Now the fourth energy level, which has 2 electrons, we have 2. So this is the electron configuration for zinc. And you can see the last one here gives zinc the valence of 2. Zinc can easily lose 2 electrons than gain 6, right, to attain an octet. Okay, so that's what we have for zinc. Let's look at potassium. Potassium is number 19 in the periodic table and has got 19 electrons. So the first energy level has 1 sub-energy level, the S, with the 2 electrons. Then the second energy level has the S sub-energy level with the 2 electrons. It has the P sub-energy level with 6 electrons. These are now how many? These are 10. Okay. These are 8 plus 2, 10. Now you go to the third energy level. The S sub energy level has 2. Then the P has 6. So we are remaining with 1. So we go to the 4, to the fourth energy level before you go to the D. So it is the fourth energy level. The S sub energy level has got 1 electron, the remaining 1. Okay. So we have exhausted the 19 electrons. Let's see. These are 4, 10, 12, 18, 19. And if we break this into the usual way, we write the configuration, find that this one, the first energy level has 2 electrons. The second energy level has 8. The third energy level has 8 in this case. And then the last one has 1, whereby 1 is the valency of potassium. It can easily lose 1 electron and gain 7 to attain an octet situation. So that is how we arrive at electron configuration, by considering more about the energy levels, sub-energy levels, the orbitals, and the electrons around the nucleus. So that is more about that. I hope this video has been of benefit to you. So I want to request you to subscribe to Samuel Academy to be able to see more videos in physics, maths, and other subjects. Welcome.